So, the year is 1990, and it's the 10th of June. It's 8:20, and we are at the Birmingham airport. The British Airways flight 5390 is about to take off. They are going to Malaga. Most of the people inside the plane are going to holidays. They take off, everything is fine. And at 8:30, the takeoff is finished, and the pilot and the co-pilot remove their shoulder harness, and the pilot loosen his belt. At 8:33, the left windshield panel is blown out. The air is going outside of the airplane, and the pilot is actually sucked out of the airplane halfway there. The door is blown inside on the throttle, pushing the throttle to maximum capacity. The chief stewards get in, rushed in, see the pilot almost outside of the airplane, and grab him with the belt. In the end, the co-pilot is trying to take the plane back into control because the autopilot is now off. And in 1990, on this plane, not everyone has oxygen, and they are way too high. So he has to push the plane down to have air for the passenger. They do that quickly, but because of the wind, when the co-pilot sends the distress signal, he can't hear what the control on the ground is saying. And after a few minutes, the steward holding the pilot is having severe frostbite and is exhausted of holding the pilot outside of the plane. And actually, they think the pilot is dead because the head of the pilot is hitting the side of the fuselage often, and he's almost outside of the plane. But they still grab him, and the rest of the staff take rounds to grab the pilot who is almost outside. In the end, the co-pilot can hear the ground control, and they land at 8:55 at Southampton, and nobody is dead. Everything is fine. Even the pilot is actually alive. And we'll come back to his work a few months after that. Hi. I'm Xavier Detant. I'm CTO at Zenica. I'm a software crafter. I love code, and I like to take some nice pictures and funny pictures. I'm here to tell you about my experiments with TCR, which is short for test and commit or revert. I'm going to answer two questions today. The first question is, what is it? And the second question is, who is it for? Let's start with the first question. What is it? So TCR is actually not invented by Ken Beck. It's invented by people that I have a hard time to pronounce the name, but I will try. So it's invented by Oddmund Stormer, Ole Jensvold Johansen, Lars Barling-Dog. And Ken Beck actually wrote an article about that. And that's the reason most people think it's Ken Beck who invented it, but actually he didn't. But it made it famous, and I learned about it thanks to that article. Raquel Carmena did an awesome job trying to draw the workflow on what is TDD and what is TCR and to see the difference. So you can see on top TDD, as you hopefully know it, where you write a test, watch it fail, or write another test, think again. Then you write the minimal code to make it pass. Hopefully it goes green, otherwise you do something else to make it green. You commit, you try to have it simpler through refactoring, hopefully keeping it green, otherwise continue refactoring until it's green, and you work like that. Now, TCR is a bit different because you write your tests, you write your code, you run your tests, and if it's green, you commit. If it's red, you revert. And then you can go refactoring as usual, almost. You refactor your code. If it's green, you commit. If it's not, you revert. Okay? And that's it. That's all it is. Okay? And you may think it's a bit extreme, and it is. So let's have an example. Okay, I could live code, but I wasn't feeling confident about it. So I didn't code, and I have the code in my slide. And since I needed to fill in one screen, I needed to be short, so I wrote it in Haskell. So let's do FizzBuzz. Everybody knows about FizzBuzz? Yes? Awesome. So FizzBuzz for 3 is fizz. Okay, I write my test. I don't run my test because I'm going to write the code that goes with it first. And this code should make my test pass. And it does. Great. Now my code is committed. You can see the change of color in my slides. When it's white, it means it's committed. Okay, so I have this code, it passed my test. Now I add another one, which says that for 6, it should be fizz again. I change my code, and I run my test, and it passed. Now it's committed. Awesome. I write another test. For 5, it should be buzz. And I write my code. But it doesn't pass, because the special case of 5 was after the general case of everything. And the consequence is now my code looks like that. I revert it. Okay? So I don't have my code, obviously, and I don't have my tests anymore. So I have to write it again. And write the correct code. Now it passed, and it's committed. Make sense? Okay. So there is some caveat with it. And one of the strongest, according to me, on a lot of people on the internet, and probably your first reaction, if you're used to TDD now, is there is no red step. You write your code of test, and then you write your code of production. But in between, you don't know if your test was actually testing anything, because you don't see it fail. Another problem is you can't lean on the compiler. Lean on the compiler is I run something that I know doesn't compile. Then the compiler gives me some information so that I can write some code. And you can't do that. Actually, you can, but you will lose your code when doing it. Another problem is your test gets reverted because it fails, which, by the way, if it fails, it's kind of a good thing because that's what you wanted to do when you messed up, but it gets reverted, and you have to write it again. And all of that can make it very frustrating. Now, a lot of people experience with this, try to find solution, and once again, Raquel did some work on it, trying to show the workflows of everyone. I'm one of them somewhere here. But in the end, it's all about doing Git stuff. It's not that interesting that it's worth a talk. So I'm not going to talk about that. It's actually very simple. Once you get the idea of TCO, you're trying to find out ways to have your red step and avoid reverting your code when it does not compile and that kind of stuff. You will find the blog of Raquel about it. You will have this diagram, simple, no problem. So I'm not going to talk about this. Is that clear? Good. So let's answer the second question, which is, who is it for? And my answer to that question is, it's for people who wants to go closer to the Limbo workflow while using the Eisenhower matrix to map that feedback. Is that clear? Not so much. OK. So let's ask another question, like, what is it for? Why does it even exist? And to understand that, we need a bit more background, especially of Ken Beck. So he worked for a long time at Facebook. And one of his main questions was, how can I help a team that works in that kind of workspace where there are thousands working on the same code base to work efficiently, seamlessly. No problem, easy to work. No big conflict with the teammate that is there while I'm here, and that kind of stuff. And one of his idea is to make changes in the code, to rearrange your workflow so that you have mostly could not possibly cause problems commits. Which means you have commits that are so simple that it's obvious to you that it won't cause any problem while running on production. And a way to do that is to have very, very small commits. And that's what he called the limbo, because of this game. The limbo, if you don't know it, you have a music, you have a bar, you have to go under the limbo, the bar. I'm approximately as good as he is on the picture. And the catchline of the limbo is, how low can you go? And the how low can you go while coding, the question is, how small can your commit be? And if you search a bit about limbo and you ask the question, how low can you go? The answer is very low. And the idea is we should be able to do the same with our code. We should be able to do very small commits. Don't get me wrong, it needs training. This needs training, okay? But you should be able, with enough training, to go very low and have very small commits. Let's discuss that later. That's the idea of the limbo, okay? So I think the limbo is by now clear. Yes? Awesome. So who is it for? As I said, it's for people who want to go closer to the limbo workflow while using the Eisenhower matrix for the feedback. Maybe it's not that clear, actually. OK, so what is in TCO for me? Let's talk about feedback. This is the feedback diagram of XP. And one thing should strike you, and I'm sure you all know about this. There is a time axis which is there about feedback coming faster and faster. And usually when we talk about feedback, we say you should shorten your feedback loop and have it as short as possible. Agree with that? OK. Let's just demonstrate why it is so important. So I will need a volunteer to help me here. Someone who would like to join me here. Anyone? Please come. Thank you. It's for playing a game. So I will give you my phone if it can work, maybe. OK. No. Let's try again. OK, just a second. So I'll make you play a game, which you will have. Yes. So awesome. You will have this screen to help you. OK, you won't see my phone actually. OK, so it's a game where you will have a big black ball, and you will have to catch small black balls to earn points. OK, and she can't see my screen, OK, because it's hidden. You press play, and you start playing when you're ready, looking at the screen here. Does it work?
No, I can press play.
Yes. OK. OK, you're learning the game. Don't worry. You'll have another try. OK, and no, while she's playing, thing that interests me is for you to look at the point she has. So far she has 15 points, 20 now, doing better. OK, and we'll wait for her to finish the game to see the score she has. OK, but the point is she's doing some stuff on my phone. OK, and see it on the screen. And she has a almost instantaneous feedback. Okay. She moved the phone. She see the black dot moving. And getting better at the game. Well done. OK, 50 points. Wait for it. So 55. When I repeated this talk, I had the bad luck to find someone very good at that game, and we spent something like 10 minutes watching the person play. So thank you so much for that. Now, the thing I'm going to do is I will add some latency to the network we have between the phone and the screen, if I can type my password correctly. Yes. So now I will ask you to restart the game, which is there. Up. Awesome. OK, and you can, you don't see anything. Yes, you do. Does it feel harder? Okay. Okay. Thank you. Now the big question is, how much did I add? Any idea? How long between she moved the phone and it appears at the screen was there? 1 second. 1 second. And she scored 0 versus 55. Okay, that's a lot of a difference. So that's one of the reasons feedback speed is so important, because if you have the feedback quickly, you can adjust quickly and be more precise. And because you're more precise, you're going in the right direction, and you're going, in the end, faster. And TCO is all about this. It's all about feedback. You have a quick feedback when doing this, like in TDD. Okay, so you should go at the speed of light while using TCO. Okay, no limit, go as fast as you can. And yet, when you start using it, it feels a lot like this. You really feel like you're not getting anywhere, at least at the beginning. Once you get used to it, you can go faster and find your speed back. But right at the beginning, it feels like this. So why? Because I have my feedback loop that goes very quickly, so I should go fast, right? I don't. And I think the reason is because when we think of feedback, we think one-dimensional. Is it slow or fast? That's it. And I think we totally forgot about the second axis, which is, I think, is it strong or gentle? TDD is more gentle than TCO, because with TCO, if I fail, I lose my code. With TDD, I don't lose my code. And let's take an example of this. No, I totally forgot the Eisenhower matrix. So the Eisenhower matrix, I think, fits a lot with this. The Eisenhower matrix is all about, is it urgent, important, both, or none of them? And urgent and important are two different things. And when we focus on is it slow or fast, we focus on is it urgent or not. And when we start to add the second axis, is it strong or gentle, we can think of it as is it important or not. Let's take an example, naming. Let's say you see some code where there is a typo in it. Is it really important? I don't think so. Is it urgent? I don't think so. You can work with a typo and it can compile and it can do stuff. It's not that important nor urgent. If you, I mean, you have control space. If there is a typo, maybe you don't even see it. So you can, if you see it, to make a feedback to the person yourself or the person who did it, you can wait a bit. But what if the name is too long? So you will have to write a lot of things and it's complicated and there is a lot of other things that start the same way. For example, you say the value of the stuff that the client is buying as a variable name. If you think that price is a better name, maybe you should say it now, because it will help the person who is coding to have shorter names and shorter code and think about the code. But is it that important? Not so much. It's urgent because it's right now helping now for while you're writing the code, but it's not important for the task that you're doing. What if the name doesn't reveal the intention? Is it urgent? I don't think so. You can live on, I'm sure you all did, with a variable that is badly named. And you worked with it, and you could write code, and you understood what you were doing. Is it important? I think it is. A lot. Because someone else is going to read your code, write that variable name, and don't understand anything about your code. It works because you're writing the code right now, but in a month, you won't understand why that variable is named bar or foo. But you can work with it at the moment. What if you name something that is named the same as another variable? You have a conflict of name. Is it important? Yes, it won't compile. It doesn't work at all. Is it urgent? Well, if you want to continue working, yes, it is. So let's go back to our story about the plane. What happened? Why did we get there? Well, 2 days before, on the 8th of June, the chief maintenance officer changed the bolts that were holding the windshield on the plane on the left side. And the thing is that bolts weren't marked, could not know which one it is exactly. In the end, he looked at it and think it was the A211 7D bolt. It was 90 bolts, and he wanted to change it because he thinks it was needed. So he goes to the storeroom to discover that there is actually only 5 left. 5 versus 90 doesn't fit. So he goes to the second storeroom. And the bad news is that's a backup storeroom. And because it's a backup, it's not as organized and maintained as the main one. So it's badly labeled. The labels on the bolts are wrong, actually. The light is way too dim to see. And actually, there is only one. So to look at the bolt, he has to put his head between the bolt and the light. So actually, could not see the bolt. Other things get wrong, like he forgot his glasses, so can't look at it properly. And in the end, took some bolts that he thinks are correct. Spoiler, it was not. It was actually the A211-8C. And as I'm sure you all know it, the difference between the two bolts is 0.66 millimeters in diameter. As you know, we are in the Liskov room, right? And as you know, some substitutions are better than others. And that was a bad one. And finally, the policy of the maintenance of the screen shield was marked as non-critical task. And the difference between the two is if you do a critical task, you have to be checked. If you don't, and you're the chief maintenance manager, you don't need to be checked. So he didn't get checked. A lot of other things went wrong for this to happen. Not just that. Clearly, it's not his fault. It's the whole system that made this happen. But what I think is the board's issue was seen at that moment as non-urgent. We can wait for the plane to land to change the boards, which is a good news. But non-important. Why I think it was actually important, but indeed not urgent. And what happened is because they missed the right quadrant in the Eisenhower matrix, the feedback became very urgent. Like, it goes off and you have to put the plane on the ground now. And I think the two axes are actually working together. Like, if you think it's something that doesn't need to be handled quickly, so the feedback can be slow, and you're wrong, even though the feedback should have been gentle, it may get strong later. And that's the reason I think we focus on the speed of the feedback and forgot the second axis, because when you're wrong, it goes up, gets stronger, hurts. You don't want to get hurt. You want to have it quicker, and in the end, it's now a gentle feedback. So I put some stuff here, some practices. I definitely not sure that is the correct position for these practices. Okay, it's just some idea from me put in that slide. But I do think that humans should focus on giving gentle feedback, while machines should give you strong feedback. Slow or fast, but humans should be gentle. That's why I see pair programming, specification by example, code review, that kind of stuff should be gentle. Whereas TCO or TDD are given by the machine directly and can be stronger. We can accept the machine to be a bit annoying to us. It's really hard to accept a human to be annoying to us. Does that make sense? Good. So, who is it for? Aristotle was a philosopher and worked a bit on what they called at that time natural philosophy, that now we know as physics. And he thought that the nature was composed of 4 elements, which were earth, fire, water, and air. And for example, because elements where something was composed with earth, it needs to go back to earth, so it falls. That was the explanation of this. And you had 2 kinds of forces, the violent forces and the natural forces. And if you stop doing the violent, like moving something around forces, the natural forces comes back and move things. So if I let the bottle go, it's the natural forces that getting down. The consequence of this is if you go on a boat, go on top of the mast and let something go, it should fall behind the mast because there is no violent forces pushing it forward. And that was basically the state-of-the-art physics for a very long time, many centuries, until Galileo actually tested. He was the first one to test this. He went to a boat on top of the mast, get something, let it go, and it fall at the bottom of the mast because of inertia that we know now. So everybody was sure that Aristotle was correct on using his work, and it totally makes sense until someone actually tests it, because doesn't know, have to test it, just check it, try things. I don't like this stuff, let's try it out. That's exactly what Ken Beck did. He said, I hated the idea of TCO, so I had to test it. And that's what I want you to do, actually. Be Ken Beck, be Galileo. If you don't like something, please test it. Thank you. I think we have a bit of time for questions, if you have some. Yes. Welcome. I tested it with unit test only. I think you can do it with whatever test you want. But if you want, because of the way TCO is by design, if you're doing a double loop, for example, you're expecting a test to be read for a long time, and you don't have a long time for it to be read in TCO. So it may be a struggle, but once again, you can do smart Git stuff to avoid this. Yes?
I have a question about feedback loops, actually. Did you ever work with, thank you, people having short feedback loops, but not using them, not paying attention to them?
Every day.
Okay, what do you do?
For example, I'm sure a lot of people here have Sonar or something that check code quality and receives an email when something is wrong, which is a very quick feedback. Like, you just committed some code, according to Sonar, something that is wrong, you receive an email, and you say, nah, do it better, do it later, and you never do. And in the end, for example, a team I'm working with these days receive every day a mail about Sonar, and a lot of them has a rule in their email client to just ignore it. Like, we know we are doing crap, just ignore it, we'll do it better later. So that's a quick feedback that they just don't use.
So I have a second question, if I can.
Go ahead.
Should there be a third axis in your diagram about the level at which you use actually the feedback loop? Because you can have, obviously you can have short feedback loops, not using them at all. So it could be gentle or strong, you don't care, you're not using it.
Maybe, yes. So the diagram I'm presenting here is clearly an idea I got once using TCO, because the only difference I actually saw about the feedback between TDD and TCO is how strong the feedback was. Because if you use TCO, you start coding for half an hour and you fail, you lose half an hour of work. That's a very strong feedback. Whereas if I do the same with TDD, it just read, you messed up something, fix it. And that's way more gentle. So that's the thing I got from TCO, is there is another axis. Maybe there is a third, I don't know. I have to work on it.
Can we still ask questions?
We still have 5 minutes, but there is more people with questions. Sorry, but we can have a talk later.
Maybe a nice question, but commit means push or just commit?
Very good question. Thank you. The commit in TCO means push. Commit on push. The goal is to be on a trunk-based development workflow. And when you say commit, you push your code and you share it with everyone. That's the reason you want to have very small commits, because as soon as you commit, it goes to production. So yes, it's commit and push.
And so the test is shared among the
Yes.
push, and the test is going on not on your computer, on your machine. The tests are not running by you.
You run it once on your machine to check that actually you run all your tests to check you didn't break anything. Commit and push. So that's the main reason why all the other ways of working is just doing stuff with Git. Like, for example, in my case, I thought that it was a good idea to do a commit, just a commit, not a push, right after the red test to have my red step. So I see my test going actually red. And if it's red, I commit. If it's not, I revert, because I like symmetry. And then, when I make it pass, only then do I push, to be sure that I share only green code.
And by doing that, when we have legacy code, for example, and sometimes development can be tricky because it impacts several aspects of the software. Is it not are we not losing the intention, the global intention of the development? We have a lot of commits, and independently they don't sometimes mean anything. And so we have big history, Git history, and sometimes it's more blurry. The big history. So what was the intention?
Have to test it. Don't know, but there is always squash. I saw someone, yeah. Sorry, Christoph. So there is a lot of prerequisite with TCO. The first one is you work on trunk-based development, and you should have a quick test suite to know if you're doing something correct or not. If you don't have this, TCO just won't work. I think it will be the last question.
Okay, thank you. On all the times where your test was red and you reverted, how many times did you change your test?
Often.
Okay.
Often, because one of the usually when I found to make a test pass quickly after writing it, most of the time it was because I was trying to do a huge step. I didn't feel like I was, but there was a way to make a smaller step. And after, let's be honest, after the 3rd or 4th time writing the same test and not making pass, then I start to think, is there a smaller test that I can make pass? Because I won't be able to make this one pass. And usually what happens is I find a small step to do it, works perfectly on the first time, add the test I wanted to add at the beginning, and it just works. Thank you.